So before we get going for today, in the previous lesson, so this is the fourth lesson in the series, and in the previous lessons, we've been doing things like we did something called the distance formula, we did something called the midpoint formula, and then we did the gradient formula. Okay, so those are things that we covered. And then we also spoke about the straight line, the form of a straight line, and how do we find the equation of a straight line. And so a lot of the time, we were using the gradient formula to help us find the equations of straight lines. And normally, we ended up with trying to work with that equation. We also spoke about parallel lines and the relationship between parallel lines. And what we ended up finding in the last lesson was that often, well, when lines are parallel, the two gradients are equal to each other. Now, just give me a thumbs up if that all sounds familiar to you, or if you completely new, that might be like, you never heard of this stuff. But I just want to do a quick check-in to see if that looks vaguely familiar to you. And if it doesn't, don't worry. I'm just getting a feel, because I don't have normal classroom. It's good for me to get a feel for the group as I get going for today. Okay, so today we are going to talk about something new called the angle of inclination, and we're going to combine it with a bit of trigonometry. So first of all, let's understand what the angle of inclination is. So I'm going to draw my Cartesian plane first of all. All right, so we've been talking about this for a while now, and we've got my x-intercept and my y-intercept. And then I'm going to draw a straight line. Let's say that the equation of this straight line is y equals, it looks like it's got a negative intercept. So let's see what it is. Let's say the gradient is 1x, and then it cuts through -3. So we'll make this, the equation of the line is y equals x minus 3. Here's my -3 down here. We don't know what that is. And my gradient is kind of, we can see we go, or if we go 2 up and 2 across type of thing. Maybe I should make it like this. So this is kind of what we've been talking about lately, the gradient and intercept and that sort of thing. Now, the angle of inclination is this angle here. So that is the angle of inclination of a straight line. And what we're going to learn today is, if we've got the gradient, how do we find the equation of, or how do we find the angle of inclination? And there's one simple formula that we need to know, and that is that m equals tan theta, where theta is the angle of inclination and m is the gradient. The reason this works, we don't have to go into too much detail on this. We may just want to understand how to use it. But the reason this works is that tan of theta is just y over x. And if you imagine a triangle being formed here, this would be y and this would be x. And if we think of the gradient formula is just change in y over change in x. So you can imagine, like, if you wanted to work out the angle of inclination, here's 2 points, and this bit over here is the change in x, and this bit over here, so that was the change in x, and this bit over here is the change in y. And so the tan of theta is just this over this, but that's also the gradient. Now, that's quite a mouthful, so I might have confused a few of you, but the main thing you have to kind of believe me and understand sort of where it comes from is that the gradient is equal to the tan of theta. Give me a thumbs up if this, if this vaguely makes sense to you, or if it sort of makes sense to you. Thumbs down if I've lost you. So the gradient of this line here would be 1, because it's in the formula, or we can visually see it. Okay, I might have lost some of you. That's fine. We're going to figure it out now. Let's just start by actually using this formula, and we'll see it together. Okay, I can see I definitely haven't got most of you on board yet, so that's fine. Let's just actually do an example. So here is an example. We have a straight line, and the angle of inclination is going to be 60 degrees. So I'm just going to put it like this. And that's the question says, determine the gradient of each of the following straight lines, given that the angle of inclination is equal to 60. So I'm showing you that the angle of inclination is 60. Now, the formula, which we're still not 100% sure of, is that tan of theta is equal to m. I want you to try and use this formula to tell me what the gradient is, what m is. Now, you'll need a calculator, and once you find it, won't you put it in the chat? So we kind of discovering this new thing to start with, and then once we feel comfortable, we'll move on with it. For now, I'm just asking you to apply the thinking here. So what should you be doing? You should be going to calculator, and in your calculator, what have you actually been given? You've been given 60. And if I put that into my calculator, I go tan of 60, and I get √3. Now, √3 is a decimal. If I hit the SD button on my calculator, I get about 1.73. And what that is telling me is that the gradient of this line is √3 or 1.73. So for every 1 unit across, I go up by 1.73. So if I go across by 1, I go up by 1.73. It's also telling me the gradient is positive, and the positive gradients go up and to the right. Okay, now I want to give you another one before I give you, I'm going to add one in myself. So let's make this, I'm going to make this I want to know what is the gradient if the angle of inclination is 40 degrees. So I want you guys to work out for me what is the angle, what is the gradient of a straight line with an angle of inclination of 40 degrees. Maybe I've drawn it a little bit too. It should probably be flatter here, something like that. So I'm going to go, well, I want the gradient, which is m. And so I go the tan of 40. Now, just using logic, if the angle is smaller, I expect my gradient to be less steep. So let's see if that works. So I go tan 40 equals, and I get 0.839. If I was rounding it to 2 decimal places, it would be 0.84. And what that means is if I go across by 1, I'm going up by 0.84. And so what I see is that that angle is, or that gradient is less steep. Like the green one is much steeper than the red one. And that makes sense because the angle is smaller. Let's try one more like this. If I say to you, what is but let's try two more. What is the angle of inclination? What is the gradient if the angle of inclination is 10 degrees? And what is the gradient if the angle of inclination is 80 degrees? I want you to tell me what you find out. You can pop your answers in the chat. So 6, which actually is 1.8, 0.18 when I round off. And then what is it going to be on this side? Okay, so it seems like we should just zoom out for a second and make sure we understand what's going on here. The angle of inclination is just the angle that the straight line makes with the positive x-axis. And using this formula, it seems to do a pretty good job of, the relationship isn't too hard. If the angle is bigger, it seems like it gets steeper. If the angle is smaller, the gradient seems to be smaller. From what I can see here, like 80 degrees, you can see it's 5.67 is the gradient, which means basically if I go one across, I go 5.67 up. Whereas here, if I go one across, I hardly go up at all, just a little bit. Give me a thumbs up if you feel like you're following me. Give me a thumbs down if you're unsure about this gradient and angle of inclination formula. Okay. No, you guys are doing great. So now, part of me is feeling curious. What if I made my angle of inclination greater than 90? So all of the angles I've given you so far are less than 90. What do you think is going to happen if my angle of inclination is greater than 90? I'm curious if any of you feels like giving me an audio comment, or maybe you feel like putting in the chat. What do you think is going to happen when I say the angle of inclination is 135? Let's go to Orokanisa. Can we unmute?
Hi, sir.
Hey, what do you think is going to happen, Orokanisa?
I think the gradient is going to be a negative.
Aha, you think the gradient is going to be negative.
Yes.
So why do you think that? It's a hard question. It's a sneaky hard one.
Yeah, it's hard.
Can you see it's like a line that's bending over backwards? It's almost like when you get to 90, you straight up. But when you bend over backwards, then the line has to become negative. That would be my sort of simple way of, does that make sense? Like if you've got a line, if you had one that was straight up, then that gradient is like infinite. If it's going this way, the gradient's positive, but at some point, if it tilts the other way, then the gradient is negative, and you'd expect your angle to be greater than 90. Okay, let's take this out for a test drive. What is the gradient if the angle of inclination is 135? So what is if the angle of inclination is 135? So we just go, yeah, so it should be -1. And let's do one more. Let's say that I want to know the gradient if the angle of inclination is 160 degrees. And then we're going to move on from this because you guys have done well. So I'm saying now the angle of inclination is going to be even more bent over. So let's say it goes all the way to here. And I want to know I know that this angle here is 160. I want to know what is the gradient of my red line. So I just pop it in here. I say m is tan of 160. And so we get negative 0.36. That makes sense to me because you can kind of see that it's becoming flatter. Even though it's going in the negative direction, it's becoming a smaller number. And that makes sense with my intuition. Okay, I think you've mastered this part of the exercise. And so if you have further questions, I encourage you to ask them later in the lesson, but I think it's time to move on to the next part of the lesson. So let's go. I want to go the other way around. So if I say to you, I have got a straight line, and this straight line has a gradient of 5.69. I want you to work out what the angle of inclination is. I want to ask, who knows what I should do differently? I know it's going to be similar, but how would I handle now having to get the other type of thing? Whose hand is up there? Let's have a look. Let's go to Orokanisa. Orokanisa, what do you think we should do?
I think what we're going to do, we're going to turn the other side, and it's going to be, what do you call it again? I forgot what you call it, but
no, it's fine. Is it the inverse?
Yeah, inverse of tan.
Tan inverse.
Yes.
Okay. So explain to me. So you write tan of theta is 5.69, and you want to find this theta thing. And so in order to do that, you apply the you basically take the inverse, or you go shift tan 5.69.
Yes.
Sometimes we write it like this. What did you get?
I got 80.03.
80.03. And
Yes.
Lisa, it looks like students agree with you. And also, can you see that it makes sense based on my drawing? If it was like 120, we'd know something has gone wrong. Fantastic. Thank you, Orokanisa, for your help. I think we need to do a few more of these. So I'm setting you guys the challenge of working out the angle of inclination for a line with a gradient of 4/5. See if you can do that for me. Determine the angle of inclination if the gradient of your straight line is 4/5. Let's say, I suppose 4/5 should be flatter than that. And it seems like we're getting 38.66 degrees based on what students are saying. Yeah, so it's not so bad to go the other direction. I just seem to have to remember that when I want this angle theta, I have to use the inverse tan, or sometimes teachers tan, and I have to use the shift button on my calculator. If you're not getting 38.66, you're probably not using the shift tan of 4/5. Okay. Can I get a thumbs up if you feel comfortable with this idea so far? A thumbs down if I am maybe going a bit fast for you, or I've lost you in any way. Okay, awesome. Now, what we have to do is we have to think about the situation where the line bends over backwards. You know, like I was talking about bending over backwards. So let's see. Okay, that come back to that one in a moment, but let's have a look at something like this. Okay. Now, in this example, it says I have to determine the angle of inclination of this line. But this one is a bit different. There's actually two things that are different. So I want to ask us as a class, what do you think my first step? I can kind of see where the angle of inclination is. It's here, but there's a lot less information given. I might have to figure some stuff out. So can I ask in the chat, what would your first suggestion be? What's the first bit of important information I need to find before I can even get clever? Okay, Vuyo is saying find the gradient. Clemelo is saying find the gradient. And if I find the gradient, I need to know that the formula is this. But I've only got, at the moment, the 0.60. Who would like to tell me how I can get my other point? Pop your hand up and I can take a comment from someone who knows how to find that other point. Who feels, or maybe in the, okay, let's go. Do we have, okay, the gradient, yes. Let's go to Imbasa. Imbasa, how would I find my second point?
Good evening, sir.
Hey.
So, sir, we have been given that the x value for the second point is 0, and the y
there's
value
2 over
is,
here.
yes, sir.
Okay, what's the coordinate going to be?
So the coordinates are going to be 0 for the x
Okay.
value and 2 for the y value.
Awesome. Can you help me with the gradient while I've got you? What would you think
No
the gradient is?
Okay, so the gradient is going to be 0 minus
Yeah.
2, and
Okay.
the denominator is going to be 6 minus 0.
Perfect. And so then we get minus 2 over 6, which is like minus a third, huh?
Yes, sir.
And that makes sense because I can see it's a line with a negative gradient. Thank you so much. You've been super helpful.
No problem, sir. Thank you.
Okay, now before we take our break, I want to ask, what do you think we should do next? We probably should take the gradient formula, and if we go m is tan theta, we know that the m is minus a third. Okay, but this is the theta that I want to work out. Can you please work out for me the value of theta, the angle of inclination? And then we're going to take a break. And I'm curious to see what you guys are getting. Pop it in the chats. Pop it in the chats. Aha, we're getting, I like it. Get those values going. There's something interesting happening here. So some students are saying it's minus 8.43, and some students are saying 18.43, but it seems the majority of students are saying negative 18.43. Now, I want to ask you something. If I look at the big blue angle of inclination, I agree. Like, I also get minus 18.43, but I notice something about the size of the angle that's making me a bit unsure. What am I noticing that's making me a bit unsure about my answer? Can you notice it too? Are you having that funny feeling? Does anybody want to make a comment about something which doesn't seem quite right here? There's something that's not quite, it's like we're doing the right thing, sort of, but it's like, if I look at that angle, does that angle look, this angle to me looks obtuse or greater than 90, right? It's like bending over backwards. And yet the angle I'm finding is negative 18.43. And that's causing me a little bit of uncertainty. Well, not really, but I want to point that out. The problem is that when you have a negative gradient, your calculator solves for the smallest angle that the line makes with the x-axis. And what it is finding is it has found this angle over here. Can you see that the line also makes an angle with the x-axis, which is this little one here? And so because this is going in the negative direction, this is negative 18.43. And this is the angle that your calculator is picking up. Now, in order to get the big blue one, all that you need to do is, because this is a straight line, all you need to do to get the blue one is add 180. So you take whatever you've got, whenever you've got a negative gradient, you take whatever angle you've got, and you've got the smaller one at the bottom. If you want to change it to the big blue one, you have to add 180 to it, because together these will add up 180. So can you now add 180 to your answer and give me the correct answer for the angle of inclination for this line? So you know that you found the little red one, but you want the big blue one. And so we're going to add 180. And what do you then get? Okay. Now, when you add the 180, you get 161.57 degrees. And that makes me feel much happier because it's greater than 90. I can see it's bending over backwards here. And that makes more sense. So we're going to practice more of these after the break. But it's just a little warning. When you have a line with a negative gradient and you find the angle of inclination, what you're going to need to do is you're going to need to add 180, because your calculator finds the one that's going in the negative direction, or the one that's below the x-axis, as opposed to the one that's going this way. And that's a bit tricky, so we'll have to practice it. Kelo Bokhile, don't worry, I'm going to do another one after the break. And so don't worry, we will. Okay, so there is another way of doing this. I'll come back to this. What you can also do is, if you want to let me come back to this after the break. I just wanted to get to this for the break, and then I'll come back and we'll practice this for the rest of the lesson. All right, everyone, I want you on your feet. I noticed a few students are feeling confused, so don't worry, I'm not ignoring you, but we just need to take a break and let our brains reset. So I want you on your feet, and I want you to be standing up. And let's start by just shaking it out a bit. So just move your arms around, maybe swing them. Take a nice deep breath. Feel what it's like to move around, maybe spin your body a bit. Make sure you don't whack anyone or any furniture. I'm sure your parents won't be pleased. Oh. Okay. Let's do a little bit of a shoulder stretch. So we'll do that. And let's do a little bit of a shoulder stretch on the other side here. Feels good. Okay, now what I want to do is I want to get our heart rates up. And we need our heart rates up, like oxygen and blood will move around our body and hopefully make us smarter. And what we're going to be doing is this new favorite of mine called virtual skipping. So you pretend you have a skipping rope in your hand, and we're going to do 30 virtual skips just to get our heart rates up, and then we're going to sit right down. Okay, start in 3, 2, 1. Let's go. 1, 2, 3, 6, 7, 8, 9, 10, 11, 15, 16, 17, 18, 22, 23, 20, 26, 27, 30. Okay. Have a seat. Hopefully that has got your heart pumping. And before we continue with the work, I want to do a little brain break. And today we're not doing Maths 24. We're just going to do a quick little. So what do you think? Something times something is 2. Something times something is 2. Something minus something is question mark. What do we think the answer to this little puzzle is going to be? And I actually haven't done this before, so you're going to have to help me. So there's been the suggestion that 4 and 2, so 4 divided by 2 is 2, but then 4 times 2 is 8. So I don't think it can be 4. So I was thinking, so 2 divided by 1. Oh, Inga. So let's have a look. So Inga has suggested that we go 2 divided by 1 is 2, and then 2 times 1 is 2, and then 2 minus 1 is 1. And so these two numbers seem to be 2 and 1, which means the final answer must be 1. Okay, I
Nicely
just thought
done,
we'd try
guys.
that today, something different. And how about 0? Well, 2 divided by 0 is undefined, so I'm afraid 0 can't get in on the action. So that's why we have to disqualify 0. Yeah, but nice suggestion, Tando. Okay, so I hope that you are feeling a bit refreshed after your brain break. Let us return to the journey that we were going on here. So I want to give everyone a chance to try and do this one. So we're going to try and find the angle of inclination of this one. But what I want to say is there actually are 2 methods for doing this. And so when well, in this case, it's not going to make a difference. So let's just see if we can do this one here. So find the angle of inclination here. And the reason I'm saying it's not going to be difficult is it looks to me like the gradient is positive here. So let's just check that we know how to find the angle of inclination of this straight line. Don't worry, Toby, that was just a little fun brain break, especially if you're newish here. That's a compulsory part. It's just sort of a random fun thing that we do to just let our brains go off tangent for a bit. So don't stress about that. Okay, so let's start by finding the gradient, and then I want to see if you guys can work out the angle of inclination of this line for me. What are we getting for our angle of inclination for this? What are we getting? Now, one of the things we have to make sure is our calculator is on degrees. Now, it looks to me like it should be less than 90, or what we call an acute angle. So that's what I'm hoping students get. So we go shift tan, and then you get the tan minus 1 of 2. And we seem to be getting 63.43 degrees. Yeah, which makes sense to me. And notice how you don't get the gradient for free now. You actually have to go and find the gradient yourself. Or maybe you could grab it from a, yeah. Don't worry, Mbasa, that's why you're here. So you must press shift tan to get that thing. So I'll give you a moment more just to take a screenshot if you want of this exercise. But what we've found is this angle of inclination is 63.43 degrees. While I'm here, Okay, let me move on to the next one. Let me not get too clever with my add-on questions. Let's go to this one. So I want you to find me the angle of inclination of this line. But what I was saying before is there's two methods for doing this, and I will do both methods. The one I showed you earlier was find M normally and then add 180. Okay, that was the method I showed you earlier on. The other way of doing it, which I will show you, but I'm not going to emphasize it, is to ignore the negative. So ignore the negative, and then because it's quadrant 2, and then go 180 minus the angle that you find. Now, if that seems like random and weird, just ignore it. I will show you what I mean by both methods, and you guys will be you'll find it easy. But for now, choose a method and try and find the angle of inclination. If you get it wrong, I don't mind. I just want you to try and figure it out by yourself, and then I will come along and give you correction. Both of these require you to start finding the gradient, right? So it doesn't matter what method you use, but you need to find the gradient. So first of all, you need to find me the gradient. What's my gradient going to be? But 1. Okay, so it feels to me like the gradient is -1. Now, in the first method that I showed you, if you go -1 is equal to tan theta, that's completely fine. And you then go shift, so that you then go tan -1 of -1, you're gonna get, I suspect, -45 degrees. Okay. Whereas if you ignore the negative, all right, so you ignore the negative and you just leave it as M as +1, then, in fact, before I even do that, let me first finish this method. For those who did it this way, did you all give me a thumbs up if you got this -45? Just give me a thumbs up if you got the -45. You know what I'm talking about. So this, what's happened is you found this angle over here, the one that's going in the negative direction. So in order to get your angle of inclination, all that you need to do is take -45 and add 180, and you get 135. Okay, so that's method 1. If your teacher teaches you method 2, you have to ignore the negative and just use the +1. And what you find then is you go 1 is equal to tan of theta, and theta is equal to, in this case, it's going to be 45 degrees. But we know that's not correct because we can see it's obtuse. So in order to bring into the fact that it's negative, we put it in quadrant 2, and the real answer is going to be 180 minus 45, which is 135. And the good news for all of us is it's the same angle, and it makes sense when we visually look at that green angle there. So in my experience, both methods are fine, and whatever your teacher uses, you'll probably get more confident with. But I just think, basically, if it's a negative gradient, you just remember, when you get a negative angle, you must add 180, because you know the angle of inclination is always a positive angle. And so if you've got a negative angle, you've just got the angle that's going in the other direction. I see there's some questions. So what I want to do is I want to get everyone working on another question. And while that question is going, I will take questions. So for everybody who is ready to move on, find me the angle of inclination of this line. And for anybody who wants to ask questions, let's have a chat. Who is hand is raised? It's Bokan. Bokan, what's your question?
So firstly, good evening. So,
Good evening to you too.
so my math is bad. I don't understand like a single thing you just said now. Like I'm so lost.
Okay, so let's go back to the beginning. Do you know what the angle of inclination is? Do you feel comfortable identifying an angle of inclination?
Yes, I feel comfortable. So,
Okay, so that's already one thing that you know. Now, do you know the formula that relates the gradient to the angle of inclination? What is that formula?
I know the formula to find the gradient, so that's the only thing I know.
Okay, so the formula for the gradient is important, and that's going to be y2 minus y1 over x2 minus x1. But do you also recognize this formula from the lesson so far? It seems to connect that bit. So those are the two pieces that you need to bring together. And let's start by actually working out the gradient together here. So what is the gradient for this particular thing? Can you help me with how we start that? Like, if I go 3 minus minus 3 for the first part, can you tell me what the bottom part is?
-1 minus 2.
Yeah. So now we have to be careful that we go 3 plus 3, and then on the bottom, it's going to be minus 3. So I'm going to make, are you okay that the gradient is minus 2?
Oh, yes, sir.
Okay, and that also makes sense to me because if I look at this, the gradient, it looks like it's bending over backwards, right? It's like it's got the right shape for a negative gradient. Okay, now I want to connect, I've done this bit. I want to connect this red block. What do you think I need to do for that part?
If I'm not mistaken, you have to find what's this theta.
Yeah. And in order to do that, this minus 2 that I found has to go into this formula. So that's the connection. Now, here's the next problem. I need to get to this theta thing, which is standing for the angle of inclination. How do I get that? Can you remember from earlier in the lesson, I used what's called the inverse tan function. Not a problem. This is the hardest part. Would you agree with me if I said the following? If I went shift tan, which basically in fact, take your calculator out. Have you got one nearby?
Yes, sir.
Okay, so hit shift tan, and I want you to put minus 2 in there and tell me what you get. So we got shift tan minus 2. What do you get? So I think I get minus 63.43. Would you get that? Okay, we might have lost you there. No problem. So if we look at finishing this question, okay, now what we've done, we've got minus 63.43 is we've got this bit. And in order to get this bit, which is the angle of inclination, I just need to go plus 180 and I get 116.57 degrees. And that is that. And everyone, that is pretty much it for today. I am going to ask Lebo to put the link to the quiz up, but I'm also going to take questions. So the last 5 minutes, I'm just going to take questions about today. But if you are feeling comfortable, you're welcome to start the quiz. Let's go to Atule. Atule, what is your question?
Good afternoon, sir.
Hey.
I would like you to repeat the sum for me, the one that has 3, -3, and divided by -1 and -2.
Okay, is it this one over here, or are you talking about this one over here?
The one at the top.
So number 1 or number 2?
Number 2, sir.
Okay. So the different parts of the grade, if we look at this, we need to start by finding out the gradient. So the 2 points on the line are -1, 3, and 2, -3. Are you happy with that statement? Like if I look at the graph, those
Yes,
are the
sir,
2.
I'm happy.
Okay. So now it doesn't matter what side you start. We can start from this point or this point. It doesn't matter. I think previously I started with the 3, but I could also start with -3 and go like this. But then on the bottom line, I have to make sure I go like this for this bit. And so I would get -6 over 3, which is still -2. Are you okay with that?
Yes, sir.
Okay, now the little part I think is using this formula over here and realizing that's what connects the gradient to the tan theta formula. And what I knew there is I sub in the -2, and then I have to use what's called the inverse trig function. I go shift tan, I get tan of -1 of -2, and I get this angle. But the problem is that angle is the angle with the x-axis that is going to the negative direction. I would like one up here. And all I need to do is add 180 to do that. And then I'll get my angle.
Okay, I understand.
Cool. All right, everyone. I think Lebo has put the link to the quiz. Please do your best and use it as a consolidation process. I hope you enjoyed the lesson today. And welcome, especially our new students. If you feel a bit unsure, remember we've covered 3 lessons already. Will help you guys a lot.